Let me turn off this light. I don't want it shining directly on the screen. Hello. So I did grade most of you had the first assignment in and it looked fine. I went over them, they look good. I don't remember anybody that had particular problems, but no questions on those? Okay, so let me go bring this up. And the first thing that I will show will be the very last thing from the first or the second assignment, which I didn't ever show in class. Soon as the Management Studio comes up. It's taking less time to set up today than last time, if that's any consolation. Hello. All right, so I'm going to try to keep this to an hour or less so that you guys can work on finishing up the second one and then, or the third one, I guess it would be, and then doing the, maybe starting the joins. The first thing I'm going to do, though, are those, I forget what I called them in the assignment, but essentially what they are is they're system queries. And I'm going to do the first one for you. And actually, so notice how it turns green. Sys databases is a built-in table that is a system table that has all of the databases. So if I do this, now it's going to tell me a whole lot more than I probably want. But over here under name, it has a list of all the databases on the server. You know, master, template, model, MSDB, community assist, automart, metro alt, book review DB, which you may or may not have. And I think I also have, you know, assignment, one example, and show tracker. So it has all of that. It has a whole bunch of other information too. Most of it nulls, but everything that the computer, that the database needs to run. One of the basics tenets of relational databases is that everything is stored in tables, even the information about the tables, right? Everything is stored in tables. The advantage of that is you can query structures like this. So I'm going to do another I'm going to actually let's use community assist. And I think there's some stored procedures in there. Yeah, so I wrote at least one stored procedure in there. So let's see what happens if I do select name from sys stored procedures, I believe. It might be. It doesn't have it. So is it just procedures? Sys dot. Procedures. And it will show me the name. Actually, it shows me all the stored procedures. So we might want to do the one that I wrote for that was USP stored procedure. So basically what you want to do for those last couple of queries is that they are sys dot queries, sys dot tables, sys dot databases, right? And they give you, and there's a whole bunch more you can do with this. You can actually understand the entire structure of your database through these queries, but they do involve like things like joining them, you know, and doing some, adding some criteria and things. Does that make sense? Okay, so quiet. All right, so I think we'll move on to joins. Most of you know, yeah.
Sorry, my type of select new procedures.
That's okay.
Why
I may have done something on mine. Do you guys have a diagram for community assist? Because I think all of these are stored procedures associated with having created a diagram. Yeah.
I only have one.
Yeah, we do.
Yeah, that's fine. I mean, these get out of sync because I'm using the same virtual machine I'm using for 3 classes. So I do things that could cause other things to be generated. Like I think these have to do with, again, with diagrams.
We didn't create diagrams.
Right?
We didn't create diagrams.
I'm not in this class.
We do have the community assistance in there.
Right. And the diagram is there? But you don't have,
You just have to add the tables. Oh.
and then do you get the other, I'm just curious, do you get the other stored procedures then?
So procedures for a table.
Well, it wouldn't be for a table. If you go back to your query and just run, oh, you're doing something else. Never mind. I would just thought if you were there, that could be the difference. It could be something else that I did.
There's a lot of stored procedures.
Yeah, so you have stored procedure. I think when you create a diagram, it creates the stored procedures for you. Everything you do in the GUI over here has an SQL translation, whether it's a stored procedure or a function or just code. There are thousands of stored procedures that are built into SQL Server. And we'll build some stored procedures towards the end of the quarter, but we will build some. Okay, so joins. And I'm going to just real quickly, I'll designate, basically we're going to first look at a cross join because that's what the book does. Then we'll look at inner joins, which are what you would do most often. And then we will do outer joins. Okay. So most of you have done inner joins before? True, false? True. Okay, so I will show you a couple of things about inner joins that can be a little tricky. Anybody know what a cross join is?
Yeah. It joins every row in one table with every row.
Yes, and it can happen by accident. All right, so there's a couple of syntaxes. In the old syntax, I'm going to do, so we're using community assist. Let's select last name, and then I'm going to select address. City might be better. City. Okay, so I'm going to say from person, and I'm just going to do a comma and say person address. Okay, this is it city? And person address is person last name. And city is okay. All right. This is a legitimate query, but this is something you might do by accident. This is the old syntax. I'm going to show you the new syntax, which is much safer. What happens is what you said, every person. So Anderson is matched, Seattle is matched with Anderson for every row. I mean, every row is matched with every other row. You might notice down here that there are 16,375 in the result. So literally every row in the one table is matched to every single row in the other table. Okay. So it's a little hard to tell with just the city, but it's actually matching it to every single address. So Anderson is matched to every single address. Maybe we should add address just to get the differentiation a little bit. Now, and I think, was it just address? It was street, right? So Anderson is matched with every single street, then Brown is matched with every single street, and then Robinson, and then McGraw, and then Tan. Every person is matched with every single address.
Would you use that as a starting point to make a linking table?
No, well, I wouldn't. But what if there are legitimate uses for it? Though I always have a hard time coming up with what they would be. Weirdly, when you create a join, underneath, SQL Server creates a cross join first, and then eliminates the rows that don't belong to the inner join. It is a quick way to generate records. So sometimes they do it for load. They'll do a cross join to create a, so you have two tables with 1,000 records. Suddenly you've got, what is it, 100,000 records. So I mean, you can do that. There's also some math, some matrix type math things that you can do with that. That's why it's legitimate. It's not a mistake. But some people do this by mistake, particularly in syntax. If you were expecting 30 answers and you got 300 answers or 1,000 answers, then you probably did something wrong. I'll show you when we do. It typically happens in the older syntax for inner joins, where you use the equal sign to match the joins rather than the current way. And this is the current way. Let's do the cross join first. Select, I'll do the same thing for here, but instead of just a comma, I'm going to do cross join person address. This does exactly the same thing. What is it not like? It's just taking a while. Should run just fine. Comma.
So you don't need to
You
select.
need select first.
Oh, I do. My brain. I thought I included that in the copy. I guess I didn't because it was there and then I erased it. So it has exactly the same result. The advantage of this is that you're being explicit about what you're doing. You're actually saying what you're doing as opposed to accidentally doing it. Does that make sense? As I said, cross-join is something you probably won't use very much. It can happen by accident, and I'll show you what the inner joins have to happen by accident. I think that's all there is to cross-joins. The book does do a couple of things where it manipulates numbers, basically creates lists of numbers with cross-joins. And again, as I said, with certain kinds of matrix type math, I think it's useful. Anywhere where you would want to show every possible combination of data between two entities. Questions? Does anybody see a real quick application for that? As I said, I've not
Make
found
a
any.
calendar, like if you have one table with the 12 months and then another table.
You
with
could.
the years.
We should try that. I never thought of doing that. I think there's easier ways to do that, but yes, you could.
Also, Google's one just applications for cross joins that I came up with, like matching sizes and colors.
Oh, okay.
Just your, I don't know.
So you have a table of colors and a table of sizes,
Yeah,
and
see,
then
like,
just join
Just
them.
list everything you want to make, like shirts.
Yeah, that makes sense. So as I said, there are applications. That's why it's not illegal. Even though oftentimes it just looks like a mess. So thanks for looking that up. I've looked before, and I usually came up with obscure math references.
I'm sure there are lots of those.
Yeah. Okay, so let's do an inner join. These you're probably more comfortable with, but I want to show you how an inner join can go wrong. And there is an older syntax, and a lot of database administrators might expect you still to do it, because this was the way it was up until, forget when it changed. It was in this century. But a lot of older ones. So I'm going to do select the same kind of thing, person, last name. And let's get their email, which I think is their username in, actually that's in person, so we don't want that. Let's get their what do we want, their phone? We could get their phone. Their phone would be in contact, person contact. So let me look at the fields for person contact. So it'd be contact info. I'm also going to include contact type key because we'll expand this in a moment. So contact info. We'll substitute contact type key later for. So I'm going to do from person, and then this is the old, and I'm going to put a comma here and say person contact from or where. My brain isn't working yet. Where person dot person key equals person contact dot person key. This is the old syntax. All right, and it works just fine. Some people prefer it because it's actually less wordy than the new syntax. Some people have more than one phone number. Notice Zimmerman has 2 phones, but one is type 1 and one is type 3, which we'll look at later in a few minutes. So the thing is, this creates the joins in the where clause, and it does the where clause, where the person key of one table, where the primary key of one table is equal to the foreign key in another table. Does that make sense? Let's say we want a contact type. So I'm going to go down to contacts, contact type, and we want the contact type name instead of the key. I drug it up there. You can do that if you really have trouble typing them in. You can just drag them in the fields. Now, why is that?
You need a comma.
Nah, it's got a comma. Don't know why it's doing that.
It just doesn't like the brackets.
Brackets are fine. I think the IntelliSense here, because I don't have that table yet, right? I need to add that table. So if I do contact type, it'll be happy. Now, the thing is, I could, and this is unhappy because it's in 2 tables. I could get rid of it. I don't need it. Good. I probably should leave it in to show you what. Okay, so contact, I wanted this as name. And then this is contact type key. When a thing is in more than one table, you have to delineate it, not person. So let's do contact See how it's happy now? I had to say what table it was from. Contact type dot contact key. You can take that even farther. It is possible to query across databases, and then you'd have to do database dot actually schema dot table dot the column name. But it is possible to do a query across databases. So I'm not going to add another where clause right now, just to show you that in this syntax, there's no error thrown here, but essentially we still get a cross join. We get a cross join between contact contact type. Where did I put it? Okay, from contact type. We have a cross join between contact type and the inner join above it. So it's joined the person, last name, and this is one set right here, and then it matches it to everything in this set over here. Because I forgot, if I want this to be a true inner join, that I need to have and contact type dot contact type key equals person contact dot contact type key. And then I get a true, that's only has 161 rows, the other one had, if I leave out the and, it had 805 rows. 161 is the more correct. So the older syntax, if you leave out an and, if you forget a relationship in there, and this can be especially easy to do when you're doing like 5 or 10 tables at a time, it's easy to forget one in your where clause, then you end up with an unintentional cross join. That's one reason why this is a syntax that you shouldn't use very much. But it's one that, as I said, was really common. And up until, not that it matters, because Oracle's in what, 11 or 12 version now, but up until Oracle 9, it was the only way you could do a join in Oracle. So if you ever go to work someplace that has an older edition of Oracle, you may have to do this kind of join. Questions on that kind of join? And then I'll show you the more preferred way. So all the relationships are in here, in the where clause and the ands. And it doesn't throw an error if you leave one out. That's the problem, really. The other syntax will not allow a cross join to happen by. So we'll do the same kind of thing. Select person, person last name, contact info, and we could do, I'm just going to do contact type name. Okay, and then we do from person, and I'm going to alias it. I'm going to put a P there. Now you can, if you want, it also will allow you to do as, if that helps you with the alias. And I would also say that if you get confused by these aliases, don't do them, but they can save you a little typing. Let me add, I'm going to add contact type key because that actually has a, just to show you what the effect of the aliasing is. All right, so I'm going to do inner join contact person contact. Sorry, cannot type. And I'm going to alias that as PC. And then I have to say how they join on P dot person key equals PC dot person key. Okay. Now contact type name, and actually is still an outlier, it isn't there. So I have to do another inner join. And a couple of other little side notes. Inner is an optional word. You can just write join. If you don't specify the type of join, it assumes an inner join. Okay, so inner is optional. I do it for clarity, but again, you don't have to use the word inner. So I'm going to do inner join contact type, which I will alias as CT.
You mean as?
You actually don't need as on any of them. As is an optional. So I didn't use it here. I don't use it, but again, if it helps you be aware of what you're doing, you know, you can always add the as. It kind of ignores it, but you can use it if you want. So this is on PC dot contact type key equals CT dot contact type key. And this is still underlined because it is in two tables. It's ambiguous. So actually, if I put the cursor over there, it should say ambiguous column name. And that's because it doesn't know which table to take it from. It actually, in an inner join, doesn't matter in the least which table. But notice that I do the CT, the abbreviation here. If I cannot use the table name, once I've abbreviated it, once I've given it an alias, I cannot use a table name there. This bothers some people that are used to normal programming protocols because you are using the alias before you declare it.
Exactly.
Thing is that SQL doesn't process in the order that you write it. So it actually goes down here and does the froms first, figures out what tables that you're using, processes the alias at that time. So up in the select, which it actually processes last, you have to use the alias that you get down there. So it's a little bit weird, but you get used to it. Those in the .NET class, when we do the link queries, they actually rearrange things so the select comes last, which is the way it actually is processed. Okay, so this is how you do the inner join, basically. You don't have to alias. It just saves you some typing. So for every table that you add, you just do an inner join, right? Or join, just join. And you have to, for each join clause, you also have to say how it relates. Doesn't matter whether you do foreign key equals primary key or primary key equals foreign key. Actually, they don't even have to be keys. They have to be related fields, right? If it's going to make sense. But they do not have to have been designated as keys. There are people, I think it's a really stupid idea, that when they build their databases, they don't designate any keys or foreign keys. They're there, but they don't actually build the constraint in. If you don't declare it a primary key, then there's nothing to enforce the fact that it's a primary key. In some ways, that's nice because then you can add data in any order. But again, the risk of getting garbage, tons of garbage that way, is really high. But generally, it's primary key, foreign key is the relationship.
So is there any issue with what order you put the inner joins in?
No,
No.
not really. It is possible that there could be different efficiencies. You know, I tend to look at it, I tend to just to keep them straight in my own head. I tend to follow the map, if you have the diagram. So I'm going from person to person contact. Person contact has the link to contact, so I'm just sort of following the trail. And it helps me to keep it straight. Also, no real limit to how many. You can join every table in the database if you want. That being said, inner joins are a little bit inefficient. And you should, if speed and is a issue in your database, you should try to limit the number of inner joins you have to do. There's a thing, we won't go into it now, but there's a thing called denormalization that they do on really big databases like Amazon or something like that. So what they'll do is, in order for the tables that you're querying from the website, they'll pre-join them. And so the whole mass of the table will be there. So like all the product information, it could be divided in the underlying database into multiple tables, but it'll all be there in one big massive table for you to query because it's faster, particularly once you've indexed it. The drawback with that is that it is possible at Amazon to buy something that they don't have. It's possible to buy something that was sold a second or two before you. And the database, they update, they refresh that table relatively frequently, but it's always possible. It's a rare occurrence, but it's easier for them to apologize once in a while. And as I said, it's a rare event. Or they can go scramble and find it somewhere. Amazon has lots of resources. But it's better to do that than to have people have to wait for their searches. Does that make sense? And so you can, what the pre-join the table sometimes happens. I'm going to show you one other danger of inner joins. So a couple of things about inner joins. What makes it an inner join? Anybody know?
It takes only the records from both tables that match.
Right, it only returns the matching records. If there's any records that don't match, they're just excluded. That's what outer joins are for, right? To bring back records that don't match. Inner joins only return matching records. So if you have any outliers, anything that it won't return them. But there is a danger with inner joins. We'll do like get how much. I'm going to do like person, last name, and I'm also going to bring in the contact info. And then I'm going to bring in donation amount and donation date. Let's put the donation date here. And I'm going to sum the donation amount. Okay. So there's a couple of tables we have to join here, right? So we still have to join person, contact, and donation. So I'll just do from person, P, and this time I'll just use join just to show that it'll work without. Join person, contact, PC on P dot person key equals PC dot person key. Inner join, or just join, I guess is what I was doing. Join donation on, let's alias it as D, on D dot person key. Why do I have no IntelliSense? Equals P dot person key, and again you could reverse that if you want. So I need to do a group by. And I need to group by everything that's not part of the, oh, I know why. Missing a comma. Oh, I did S. It's weird. Okay. So I need to group by these three. And I guess I'll do it by name. Now there's going to be a problem here. All right, so like, notice the bishop has two donations, but he doesn't really. Might be a her, not sure. There's two phone numbers, so the donation gets duplicated here. Right, so if you were looking at that and not aware of the fact that there were two different phone numbers involved, you would think that Bishop had done something around $2,900. I mean, not $4,900. And they have not, right? It's a danger. Even if I take the contact information out, then it gets even, it still will do that. It'll still include that doubling because of that inner table. So notice there's still the 22450, even though we aren't seeing the phone number anymore. And if you notice, they're on the same date. The inner join, if you have multiple tables, and if there's a table that has multiple values, it'll duplicate the results for all those values. So if they have multiple phone numbers, it'll duplicate the donation for each of those phone numbers. That can be a real problem if you're summing things up and are unaware of it, when you have to link across multiple tables. There's a couple of things you could do if you really had to go through that table. We could do distinct, and that should eliminate, yeah, that eliminated the duplication there. The other thing is, don't include tables you don't need to. So if you're trying to figure out their donation amounts, don't include their phone numbers. That would be another thing. But it is a danger. You can do math, you can get sums, and you can get false values if you're not careful with your inner joins. Does that make sense? Because it basically returns all the matching records from all the internal tables, even if they're not fields being shown from that table. And distinct doesn't always protect you, but usually it will. If I included the phone number, distinct wouldn't help me, because there are different phone numbers for that person. It's just that he didn't donate 2 different times with 2 different phone numbers. It's just that Bishop happens to have 2 phone numbers. There's a few others that have.
How'd you get around that problem?
You'd have to do separate queries. Or, yeah, I mean, you could do that, but you'd have to know that if they have multiple phone numbers and you're doing the donation amount, you're going to get the same donation amount for every thing, right? So you couldn't use it as a sum to figure out how much money you've taken in, or even how much money each individual has taken in. I don't have to do it with contact info anymore either. But I never needed contact info in this query. I would just have them as separate queries. Okay. There can be issues with counting that are similar, right? Counting things. And if you're doing an average or a sum of the whole table, you have to be careful you don't get duplicate values if you're doing joins also. What else would I say about this? Nulls. I don't think I ever mentioned this with aggregate functions. What does sum do with a null? It ignores it, which can be good or bad. Usually with a sum, it's fine. right? So it just ignores the rows. It's a little bit more of a problem with average. Because, so if you think of and the average is a mean average. So if you think of the average as the number of rows, or the total value, the sum value divided by the number of rows, any row with a null in that area will be ignored. So the number of rows will be different than you might be thinking. Okay, so that's something to be aware of. There are functions that will turn all nulls into zeros if you want, although technically a null isn't a zero. You know. Or you could do a query ahead of time, which eliminates the nulls from the sum. There are lots of things to think about when you're doing these, and the more you get into the real world, the more complicated those things to think about become. Any other questions on inner joins? They're pretty easy, other than when you're using aggregate functions, you have to be careful. And again, you can join as many as you want, as long as there's a path. The other thing is that if you want, there has to be a path. There has to be something between the tables that can get you there. If you have a table and to join it, you have to go through 3 or 4 other tables to get there. Even if you don't want any fields in those other tables, you have to include them in the joins. Right, so let me look at my diagram. In my diagram, almost everything goes through person, so I don't know if that'll work, but let's look at it. Okay, come on. Well, so if I wanted to have the name of the job title for every employee that did the service grant, so you wanted to join, you wanted to get their job title, we would have to go service grant to employee, job title to job title. Okay. So we'd have to, the join would have to include all those tables. Does that make sense? Do you need me to do that join or go on to outers? Okay. There just has to be a path. So, you know, to employee job title, you can sort of see with the join, there's a path that goes there. So that if I wanted to see the job title that goes with this employee key, I would have to go to employee with the employee key. There's a thing that combines, this is basically links job title with employee, because different employees can have multiple jobs, right? So there's a link between the title and the job. So I could go to the job title key and then go up to the job title key there to get the name. Okay, let's do some outer joins. And then I think we're essentially done with joins. There are some weird variations of some of these, but I just want to get the basics across. So an outer join returns things that don't match. Technically what it does is it returns all the records on one side from one table and only the matching tables records from the other table. So for instance, in service grant, there are all the services that have been requested and granted. If I go to the service, community service, so let's do select service name. And I'm also going to do service key from, and I'm going to start with community service. And I'll call that CS. And I'm going to do a left outer join on service grant, and I'll call that SG. And you still have to say how they relate. On SG, well, let's start with CS dot service key equals, oh, I spelled community wrong. I was again wondering why I wasn't getting IntelliSense. On SG dot service key. And again, it's this one, it's really important that I do this as SG dot, because unlike an inner join, it doesn't return equal. It doesn't return just match. So what I'm going to do when I run this is it will return, actually, let's do it distinct. I don't need to see every issue. All right, so childcare's, the service key is 3, closes 10. Dental is 6. These are the things that are in there. Notice I have 2 nulls. Okay, what do those nulls mean? Anybody?
That's the road that doesn't match.
Right, those are rows that don't have a match in service grant, which means that nobody has ever asked for holiday money or funerary money. Nobody's ever asked for those. So those are the, those are non-matching. One way to see just the non-matching is to see where SG service key. So this is the service key and service grant is null. And then you would have a list of only those services that have never been asked for. This is really useful for doing things like finding a customer that never made an order, right? Or if you have something in your inventory that nobody has ever purchased. It's useful for that kind of thing to find mismatches, to find things that are not left out. It's quite possible, you have a customer that's, particularly if your database isn't really well organized, somebody could have started an order, canceled it, and they're still, there are other, there are lots of things where you can get mismatched data like this. So this is a useful query. They get a little tricky when you mix inner joins and outer joins. Getting the logic of that can be a little bit quirky. Also, the word outer is optional. You could just say left join. You don't have to say left outer join. Just as inner is optional, outer is optional. If you have the word left, it knows that it's an outer. You can also use right. Anybody have a guess as to what the difference between right and left is?
So whichever direction you pick, it's that table that you have all the records from.
Exactly right. Yes. Oh, left means that the first table listed, which in our case is community service, is going to list all the records from that table. And it's only going to list the matching records from service grant. If I were to say right join, it would do the opposite and would actually not get any nulls because there are no service grants that aren't matched by the community service table. But the difference between left and right is just which table returns everything. That being said, I always think left, not right. There if I were Hebrew.
Yeah, I was just thinking.
I would flip
Going top
that.
to bottom.
There are other languages that read right to left too, aren't there?
Yeah, Arabic and then
Chinese.
Chinese can kind of go in any direction.
Yeah, Chinese doesn't go. It goes right and down, right? Yeah, right and down. Yeah. So, I mean, to my mind, just English being my background, I guess, leftist is what always occurs to me, and that's what I always do, but there's nothing to keep you from doing it the other way if you want. But if to make it meaningful the other way, then what I would have to do is to say from service grant SG, right outer join community service. I'd still want the same tables, I just flip where they are. There is such a thing, and I'm not sure if the book covers this or not. I'm going to copy that. And instead of a left outer join or right outer join, I'm going to do full outer join. Oh, that still has the where. Let's leave the where off. It should have exactly the same result in this case. But what the full does is it returns all of the records, whether they match or not, from both tables. All right. So a full outer join is kind of left and right combined. Both tables, it returns all the records, whether there is a match or not.
So the left only shows
The left
only shows the extras from the left table. The right only shows the extras from the right table, and the full shows the.
It just basically shows all the records from both tables, and then if there's no match, so you get them all. So.
But in this case, there's no non-matches on the right.
Right. Yeah. So
it's the same.
Exactly. Yeah. There is no.
So we could add a record to do that.
We could add a
record on the
except
right
that the foreign key constraint and service key will not allow for a key in there that is not matched in the service community service table. One of the things is that you shouldn't have too many of these. Now, again, you could have a service that nobody ever applied for. You could have a product nobody ever purchased. You could have things like that. But if your foreign keys and your keys are set up properly and constrained, you shouldn't have anything in the child table that doesn't relate to the parent table. That shouldn't be a possibility.
So you might use this to just check the integrity of your database.
You could,
right?
yeah, you could. And for what it's worth, real-life databases are often really horribly constructed. They often are a hodge of things that have happened over time, and there could be tons of garbage in them. So outer joins are one of the ways to help start to locate some of that garbage. Again, if your referential integrity, which is the key thing, is correct, you shouldn't ever have a sale without like a customer or something, or a sale that's not hooked to a product. But if you're not paying attention to your referential, if you didn't make those keys, you could have a sale and have no idea who purchased it. No customer, no. It could be, it could get to be a mess fairly rapidly, which is why you should do the referential integrity. I think that's all there is in the joins. Is any of this, you guys have done this fairly, without too many questions. Any questions on them? I'm just trying to think. So I don't think, I might have asked you to do an outer join with an inner join above it. Do you need to see an example of that?
I think that would help just to like get the logic of it.
Okay, so what do we want to join here with an inner join? We have the service name, service key. Trying to think of what I want to join. If I have anything that makes it. All right, let's do, I don't know that this will work, but we can add an insert if we have to. I'm going to select person last name. Person, I guess last name is good enough. Contact info and contact type key. And actually I want, okay, so from, I'm trying to think. Let's do contact type name. I'm thinking this through as we go. So I want to do it from person P except that okay, we can do this. Inner join person contact. P dot person key equals PC dot person key. So this is our inner join. We're joining contact info and this. And what I want to know is, and so what we'll do is write, and I'll just leave out outer so you know it works. Write join contact type. So we want to return all of the ones from contact type. On contact, well, on CT dot contact type key equals PC dot contact type key. Now, first of all, I'm going to just see if there's any nulls. And I might do a distinct. There is one null. Oops, distinct have to come after select. So fax is null, right? Nobody has ever listed a fax. And again, if I did where, and then it would be contact type name. Actually, it'd be contact info, probably, where contact info is null. And then we would just get the fax. We could have done person last name is null too. This time I did do a right join because of the way I was setting it up. The inner join, when you're doing this, the inner join is a complete block. It's like one table, one half of it. And then the right join below is another table. So there's still always two entities, but the inner join is treated as one thing, and then the outer join is the second thing, right? So these are combined into a single table as far as it's concerned. And then this is the outer one. So it's going to return, because I said right join, everything in contact type, even if it doesn't have a match, right? And the only thing that doesn't have a match in the contact list is the fax. There's nobody listed a fax. If I execute it without that, we'll see that there's that. Everybody else has a home phone. A lot of people have cell phones. There are some, I even have a pager. Okay. I think I might only have cell phone, home phone. Did I say work phone? Yeah, work phone. But nobody has fax in there, so that's why it's. People still do use faxes, right? Probably more than pagers these days. Yeah. Does that make sense? The trick with when you're combining the joins is all the inner joins go together as a single block, right? Now it's possible that you could do an inner join after the right join, and then what you would have is that there could be two tables in the right join as well. Does that make sense? I treat it as one. It can get really complicated.
So the right join process is after the inner join.
So yeah, so it's partially the orders in which they're listed. Because the inner join comes first, all of this is treated as one block, and this is treated as a second block. If I did an inner join after this one, it would be part of this, the second block. So it basically creates a temp table based on the inner join above. And if I had another inner join underneath, it would be, I can't think of how I would do that right now, but it would combine the two as the right table. Does that sort of make sense? Just keeping track of that can be a bit of a, I've seen joins that are, you know, half a page long, which combine inner and outer joins. And if you keep track of what you're doing, that can work, but it can also become a mess really quickly. All right, so I've taken an hour. I want to give you an hour to work. Again, these joins aren't too hard. I think what you'll find is the next thing that we do, which is subqueries, is more interesting.
Interesting.
Yeah. Some people find them, they're really useful, but the logic can be harder to follow. They can be a little confusing. I will post this on the blog, and I did videotape it. So I'm going to kill the tape, and hopefully, so should be stopped. There it is. So stop sharing and stop